Okay, so meanwhile, people are still joining. So as you can see, we are going to start with the probability intro today. And I hope you have done some revision, okay? Because some of the high school ideas will still be in play, but we would try to learn a few new things as well today, okay? Okay, let's give people a couple of minutes, and by 8:05, I will definitely start. Okay, let's start. Okay, could you look at these sentences and tell me what do I mean or what do you feel when you read these sentences? Okay, so maybe let's kick off the what do I mean really? Your odds of coming late to office is 40%. There is 50% chance of rains tomorrow evening. There is 0.33 probability of you failing. No one can be 100% sure about outcome of the lottery. A fair coin has a 50-50% chance of either heads or tails. Team India has a solid chance of winning against Australia. So what does these sentences really signify? Anyone wants to take a gander? Come on.
Might be assumptions.
Assumptions, but they also kind of represent uncertainty because you are never sure about her. Like
Yeah,
you are not 100% sure, or like you cannot be definitive. Okay, you are like, yes, I can try to produce or I can try to predict few things, but I cannot be 100% correct, right?
correct.
All right. So fundamentally, uncertainty. That is where we are gonna go now. And remember, this is non-deterministic world. Okay, we are not dealing in deterministic world where everything can be perfectly determined. There would be some failings or we will miss something. Okay, so let's see how to include that in our findings. And oh, sorry. Okay, so mathematical or natural phenomena has been classified as two. Okay, what are these two? One is called deterministic, the other one is called non-deterministic. So can you define what is deterministic? We did like cover the basics yesterday, but still, what is deterministic phenomena, or what do you think deterministic really means? Just explain in simple English.
which can be determined.
Okay, which can be fully determined. So let's say if I can, I have to go in paint for this. So again, if you remember for yesterday, I gave you this kind of equation sorry, mx plus c, which can be equivalent to y. So if m is given, x is given, and c is given, y value is fully determinable, right? And let's say this is it. So can you tell me what is the y value?
Different.
Right. So you don't have any doubt here that what it would be, right? And this is this kind of mathematics that you have done so from childhood is called deterministic. Okay. This is the deterministic world you live in. There is no doubt. Once you solve, right? There is nothing to be like doubtful about. But unfortunately, a lot of phenomena fall under non-deterministic world. So if you want single line definitions or something, a deterministic phenomena is there exists a mathematical model that allows for a perfect prediction. Means no doubt you exactly know what you are solving for of the outcome. Many such examples exist in physics, chemistry, the exact sciences as well. But then we venture into this world of non-deterministic phenomena. There doesn't exist a complete mathematical model that allows for perfect prediction. Means there is always some kind of irregularity, or how do I say? There is always some amount of uncertainty you are dealing with. Okay, this is clear.
Yeah.
Okay, now the idea of non-deterministic, as I explained you yesterday, is itself fractured into two spaces. One is called haphazard, one is called random. Or random basically means stochastic. Now, if you want to write it down because these are important definitions. Random or stochastic phenomena. You unable to predict the outcomes, but in the long run, the outcomes exhibit statistical regularity. What it means is they adhere to certain functions or some kind of distribution is ruling the data distribution or the way data is defined over there, some kind of function. So let me show you. It would be better if I just draw it here. Let's try to draw some random points. Now try to tell me which describes this data distribution the best. This line or this curve.
The curve. The curve.
Yeah, very good. Even there is a randomness or noise, but many of you can immediately see this, that this curve is a better representative of these data points, right? This is where we are going. But remember, neither the line, neither the curve allows for perfect prediction. There would be mistakes, but roughly you can approximate. Get the idea? So if you can kind of distribute, or if you can figure out your data in terms of distribution or some kind of a function means f of x. Now this, what is this function? I don't know, right? Although there are tools where we will kind of try to explore and try to understand this, but right now I don't know. So if it adheres to certain probability distribution, sorry, it is a stochastic. So in short term, if you just had to point the very next point, it is almost impossible. There's randomness and you can do nothing about it. But over the large spectrum, you can make a prediction. Am I correct? So you get the idea of stochastic. Okay. And of course, there is something called haphazard, which is totally unpredictable, and there is even in long run there is nothing. available. Even in long run, still it is haphazard. Okay. So if you want to see, this is how the world is fractured. So the non-deterministic world kind of also is fractured between haphazard and random. Okay. So we will mostly operate in this world till random. Okay. You guys are clear?
Statistical representation as in Paint, you showed that. So it was just a random thing, correct?
Yeah, it is. These are random points, but the idea is maybe just if I just ask you to predict the next point, you won't be able to do it.
That is okay.
Yeah,
So
but
that will be the next one. What is that? The random and another one?
stochastic random, this is fx, if this is the question, this right?
Yeah.
Or fx is function of x.
Okay.
I'll be using these kind of signs time and again. So fx basically simply means function of x, which means is x is the parameter on which, so like fx could be x squared. It could be simply
Depend upon the situations. Okay.
yeah, any kind of
Yeah.
distribution, any kind of
Popular.
function. Okay. Right now you don't know which function, but try to understand it would be a function of x. Okay.
Okay. Okay.
All right. This would be coming incredibly helpful in machine learning as well.
Yeah.
So what are the examples of stochastic phenomena? Example, tossing a fair coin. So we have two outcomes, heads and tails. Now, if I just ask you to predict the very next toss, can you exactly predict what is gonna come and can you stick by it?
No.
Yes, very good. But again, as I explained yesterday, in long run, you can say if it is really a fair coin, there should be a uniform distribution. What does it mean by uniform distribution? That both heads and tails.
Equal, yeah?
Yeah, very good. So you can say maybe in for long run, maybe for 2000, 10,000, we are gonna get almost equal number of heads and tails. That is the prediction I can make. And this is the idea of stochasticity. Similarly, you can take another example, rolling a die. So how many sides a die has? 6. Okay. So by using symmetry, uh, you are basically, how do I say?
The cube size is same.
Exactly. What other examples you can think about? Any other example is easy.
Cards,
Sorry, what did you just say? I did
cards,
not.
cards.
How? Cards. Okay, fine. Yes, cards are the same example. Okay. Let me see if someone else has answered. Cards. Okay, okay.
Stock market.
Yeah, stock market still is very much haphazard. If people come out with algorithm or something that is very stochastic, believe me, people will crack that and they will leave no money for anyone else in the market. Okay, for
Can we say
theoretical,
weather forecast? Because they
no,
sometimes
whether
predict,
for,
or
yeah,
it's haphazard.
yeah, you can predict it for the range of 10, 12 days, but still like weather is still very much considered haphazard as of now. So yeah,
Okay.
with more sensors or more information, it might become stochastic, but still like best predictions you can do is for 10 days. Basically, a lot of people have said after if someone is predicting beyond 10 days, they are just joking. Okay, it is almost next to impossible to predict 10 days or beyond 10 days in advance.
Can we say life expectancy? Like, they usually base it like, based on the economy and medical facilities and all
Yes,
this
you can say
healthcare
that.
system.
You are right about that. Based on the current scenario, even when we are doing this, how do I say, the COVID visualization and stuff, we can see the exponential growth, right?
Yes.
So yeah, people are doing that, and that is considered stochastic. Okay, cool. So let's get on with some definitions. Again, I don't want you to like just remember them, try to understand it. Okay. So the very first definition is sample space. What is a sample space, guys? The sample space, denoted by a capital S, for a random phenomena is set of all possible outcomes. All possible outcomes. So in Venn diagram, it is the whole rectangle. This is called sample space S. Okay. So I will ask you to calculate something. Please be ready for the calculations. Okay, so when you toss a coin, your sample space is heads or tails, right? If you only toss one coin at a time. When you roll a die, how many outcomes you can get?
6.
6.
What about two dice? If you have die 1,
36.
combined, if both of them are rolled, that is
36.
36. Okay. Any other answers people can think?
30.
Sorry,
30.
30, 30.
Yeah.
How?
Because one, if both are having same, it can be treated subtracted.
Yeah, so basically what will happen is, basically you should ask a question, do these die looks different or they look exactly the same? If they look exactly the same, then you are in a trouble because this configuration and this configuration is exactly the same. Remember, you are throwing the die. So the idea is if they both are identical, how would you know which one is which? So let's calculate. This might feel manual, but believe me, it will work out. Let's say you have two dice, but they are not different in color or shape or size. They look exactly the same. So let's start with one die just getting one. So what are the other options you can get?
1, 2, 3.
Yeah. One sec. Let me just do this. Okay. And then let me use this. Okay. This is correct. Now, when I do 2, so what are the possible options?
1, 2, 6. I mean 1, 2, 3, 4, 5, 6.
Yes.
Uh,
Although, now because you cannot track them, aren't these two similar basically?
1 comma 2 is the value is same and 2 comma 1 is the same only.
Right. Both dice are similar and I throw them. So if they go certain distance and you cannot track them physically or through your eyes, how would you tell the difference which one is which?
Which one is the first and which one is the next one?
Exactly, because they are not of two different colors. They are exactly looking the same. So this is why I said you should ask, are these dice of two different colors or they look very different? Because fundamentally what it means is, can you track these dice, yes or no? That's the question. Okay, because you fundamentally throw the dice, so it's hard to track, right, if they look very similar. So even if the one die is 1 or 2, even if I reverse them, how it is any different? It is still the same. Did you get the idea? And both of them dice are thrown at once. They are not thrown one by one, remember. They are thrown at once. So this is the problem. But okay, so fine, you can eliminate this, but you can keep So I will ask you to take a leap ahead and tell me what is the total number, sample space number. You understand what not to count
21?
again? So what's the total number of cases, guys? Come on.
21 might be.
How did you add?
20, 23.
I think you took 6 plus
Yeah. 5 plus 4 plus.
the 6 would be the last one, right? Okay.
Yeah.
So what is the total number? Can anyone calculate?
21.
So the sample sizes or sample space size is 21.
Yeah.
So you have to be careful to not go blindly like 6 into 6 is 36. This is what gets you in trouble, right? Not all the problems are same. Remember this part. So you have to think very carefully. Just by changing 1 or 2 words, I can make the problem really hard. Okay? Everyone is clear?
Yeah.
Cool. Okay, let's get back.
But how to do it in the formation of the formula?
Yeah, it will come. Don't worry. We have
Yeah.
just started. Don't worry. It will come.
Okay.
And okay, so this is sample space S. What is event E? The event E is any subset of sample spaces. Remember, it should be sample space, a subset of sample space. Any set of outcomes, not necessarily all outcomes of the random phenomena. Okay. So it's kind of a some area inside the sample space, as you can see in this Venn diagram itself. So event E is said to have occurred if after the outcome has been observed, the outcome lies in E. So let's take an example to understand this, otherwise this might become very confusing. So rolling a die, what are the possible outcomes? All the possible outcomes.
6, yeah?
1, 2, 3, 4, 5, 6, correct. Now event E could be that even number is rolled. So what is the number here?
3 only.
Even numbers in die are
2, 4, 6.
2, 4 and 6, which basically gives me the overall number as 3, right? Okay. So what is probability? So probability of event E is number of E by number of S, or we like to write it as capital N. Okay. This is what probability is. Is it clear to everyone?
Yeah.
Now there are special events such as null event. What is a null event? The event that contains no outcomes. So the entire event, the sample space. So remember, this is the difference fundamentally. Null is represented by phi. It is pronounced as phi. The event that contains no outcomes. The entire event S, sample space S. The event that contains all the outcomes. So the empty event phi never occurs, and entire event S always occurs. Is it clear? So the probability of phi is and probability of S is any problem you can ask me right now.
Can you please explain again?
Okay, what is phi?
Yes.
So phi is the event that contains no outcomes, means zero outcomes. Okay. So how do you calculate probability?
Desired outcome over
Total. Yeah,
total,
desired
yeah.
outcome over total number. So
Yes.
total number is represented by capital N. Okay.
Mhm.
So desired outcome has no outcome. So 0 divided by capital N, that will lead you to
0, yeah.
very good. And what about the sample space S, which always occurs? So the size of sample space is capital N. Capital N divided by N is
1, yeah.
1.
The entire event, the sample space. So the entire event and the sample space, yeah. So they are synonymously used.
Yeah, you can say entire event or the sample space S. Both are very much
Same,
similar.
yeah.
Yeah, same. The S is the event that contains all the outcomes. Let me see the chat. Yeah, we will come to the examples, don't worry. We will go for all the examples one by one. So actually, you know what? Let's do one exercise first. Okay, so I will give you the probability equation and you have to tell me few values. Okay, so probability of event E is n of E is number of events in E, and capital N is overall space, that is the number of events in sample space. Okay, now use a question. Give me the probability of getting prime number when we roll a die. Calculate.
1/2.
1 by 2. So first, how do you go about it? So first I have to define E is number of prime numbers from 1 to 6. So which are these numbers?
2, 3, 5.
Good. So what is the total number?
6. 1, 2,
No,
3,
no.
4, 5.
Oh, sorry, total
Oh,
number of
oh,
the
sorry, 3.
field. And the total N, capital N is?
6.
So the probability of event E is?
3 by 6. 1/2.
Everyone got it?
Yes.
Okay, if any confusion, ask me and we will take a couple of more examples. This is basically a set theory idea. What is the union? Like let's say we have two events at the once, okay? Not just one event, but we want to get the union of two events.
Common
How to get?
space.
Sorry, what did you just say? I did not get it.
The common space between A and B.
Yes, very good. The common space between A and B. So how to calculate it? A union B, E is E belongs to A or E belongs to B. So how to calculate A union B?
Total number of outcomes in A.
Very good. So let
Total
me
number
write it
of
like N of A.
N of A plus N of B minus N of A intersection B.
Very good. Why did you do this intersection part?
because intersection part will be counted twice when we are adding n of
Exactly.
A and n of B.
So if
So
you
that
add
will be
directly, what happens is this area gets counted or added twice. So this is nothing, this is just A intersection B. Okay. So basically you remove them and whatever is left is A union B. Okay. So that we don't have any repetition. Okay. So how would you know in computer science language that it is a union?
They
If
use this
even
join, right? Join.
yes. So you have to remember this one or operator. What is this or operator? Okay. So or is kind of a logical one sec. Or is a logical operator. So what is the property of or? Anyone knows the truth table of or?
False, false is false, and rest of them are true.
Anyone is false is the false.
Basically, the way I try to remember is any one of them is true, then it is true as well. So when it is true and false, okay, so false is, so basically we are dealing in false or false. The output is 0. False or true. The output is
1.
very good. True or false. The output is good. True or true. Output is
1.
this is the truth table of or. Similarly, can you tell me the truth table for and?
except for true and true, everything is false. I mean,
Yeah, very good. You are correct. So if I am taking something false, true, false, true. So apart from this one, everything is 0. Ever anything becomes false, it immediately becomes 0 as well. Okay. So or is nothing, it is union. And is intersection, means both needs to be true. Okay. Everyone is clear?
Yeah.
If you want to write it down, if you did not know, it will be a good time to write it down. Okay. So what is the intersection?
Common elements, yeah.
The common event which belongs to A and B. Remember the keyword and. Okay. This is called intersection. So E, the event E belongs to A and E belongs to B as well. So this area is called the intersection. And how the intersection is calculated? Can anyone give me the equation?
It is just a plus of that of n of A, n of B plus
N of B.
plus
Yeah.
the intersection of
Yeah.
plus
You are trying to get the intersection of A and B.
minus A union B.
Sure. Okay. Yeah.
yeah,
Basically.
that is also,
Yeah. Basically is correct.
yeah.
Okay. So the keyword which you need to look out for is and. You see and, it means intersection. So what is the complement? Complement is nothing, it's not operation. Not of A is represented by A bar. Okay. So it's simple. A bar E, event E does not belong to not, belongs to A. Is it clear? So if this area, this white area is A, rest of the whole area is what? Yeah. Clear? So if you wanted to get the count, so what it means is event A bar occurs if the event A does not occur. So wherever A is not true, A bar is true. Okay. You guys are clear for all the three operation or and not? Okay, moving forward. So how do you recognize which problem you are working with? If you see the word or, you are dealing with union. If you see the word and, you are dealing with intersection. And if you see the word not, you are dealing with complement. Are you guys clear about this?
Yeah. Yeah.
Now a few more definitions. Mutually exclusive. And this is a big one actually. Two events A and B are called mutually exclusive if A intersection B gives a phi or null event. What it means is there is no commonality between A and B. There are no elements which are common both in A and B. So such events are called mutually exclusive. Like, let me give you a good example. These are mutually exclusive. Why?
Or
Even
can
number never be a odd number.
Can you repeat? Sorry, I did not get that exactly.
I mean, even number can never be an odd number, so
Yeah,
they are mutual.
basically there is no number common between odd and even. So if you try to take odd intersection even number, what it would output?
Obviously false.
Phi. Basically, whenever it is a null event, it's also called a null event. So such events are called mutually exclusive. So if two events A and B are mutually exclusive, then they have no outcomes in common. Means what they mean is they cannot occur at the same time. The outcome of random experiment cannot belong to both A and B. So basically there is no commonality between A and B here. There is no set of element or There is no element which is common to both A and B, and which you can see very clearly in the Venn diagram here as well, that they just do not intersect. Any questions?
So the head or tail of single coin, we can call it as a mutually exclusive.
Heads and tails, yes. If it's a single coin, yes, you can call it.
Okay.
Any other examples you can think of right now? Let me see the chat. Switch on and off. Very good example, actually. Yeah, switch can be either off or on. Okay. So basically, this event, if you try to take a intersection of them, you will get nothing. Okay. Probability of an event E, and basically this is the same idea. There is nothing new, but if you want to write it down, you can write it out. There are few assumptions though. So when you are using this equation, remember there are two assumptions. First, the sample space has a finite number of outcomes. So this capital N is a finite number. It could be a large number, but it has to be finite. Each outcome is equiprobable. Okay. So all the E events are equiprobable. There is no biasness. So I should write it. No bias, basically. So in this case, you are assuming there is no bias in the experimentation or the system. If it is, then you cannot use this equation. So you should try to write it out or try to remember this one.
Well, what was the P of E? E is the event. P is
Yes, probability.
a probability. Okay.
Yeah, I hope you remember the chapter, right?
Yes, yes.
Okay.
There is no difference between the first and the second, right? Number of E and number of samples. Sample and number of outcome both are same.
Yeah, so basically number of samples is represented by a capital N as well. So basically this is not number of samples. This means number of space or whatever the size of sample space is. That means total number of outcomes. Was that your question?
Yes.
Okay, let's see few rules of probability. So how do you add in probability? If it is a mutually exclusive event, they are saying PA in union B is P of A, probability of A plus probability of B. How is that possible?
No intersection.
Very good. Because you can remove the probability right now, and you can talk in terms of A plus B minus A intersection B. But A intersection B happens to be, if it is a mutually exclusive event, then
Null.
or zero. It will basically equate N of phi is zero. Okay. So probability of probability of A plus probability of B, because the rest of the part is zero. Is it clear? If any doubt, you can ask me right now.
Then A of A union B and A intersection B are also the same only.
Sorry, I did not get it. You are saying both are same.
Yeah, might be.
How?
Because A union. Okay. It is the intersection. Okay. No. I don't.
All right. Oh, sorry. My bad. This one is the correct slide. So simple. What we are really asking is A union B. So what was the definition of union?
Common space
Elements
between A and
occurring
B.
in both, yeah?
Sorry.
Elements
Both.
occurring
Yeah,
in both.
common elements. So if there is no intersection, wouldn't just adding them would solve the problem? Look, earlier, why did you have to put that negative sign over there, negative part? Because of the common element, but there is no common element here. So if you just add A and B, you would get the union. Now it will contain all the elements which are contained in A and B. But this is the general rule, so do not forget that was for mutually exclusive, but it is better that if you remember this rule. P of A or B or means union is nothing but probability of A plus probability of B, and this is the intersection. Okay, so this is how it looks like. Any doubt with this equation? How does this work?
No, it's clear.
All right, solve this. So this is a question and I want you to solve this. So tell me the final answer. How would you solve it? Okay, let's see.
47%.
How did you calculate this?
37%.
Okay, so what is the line of thinking? Can anyone explain? So basically what we are
So,
finding is we are trying to find the probability of this because
yeah.
it is written Saskatoon or Monton. So basically union of these. Okay. So it's a very
So,
simple maths. We just have to put the values correctly. So
0.02.
20%. So let's put 0.2, 0.35. And what is the intersection?
0.08.
0.08. Very nice. So what is the So this is plus, this is minus. What is the value?
0.47.
Okay, 0.47 or 47%. If anyone is unsure of maths, this is how it will go. So you have to define, let A, the event that Saskatoon is among the final 5. Event B, the event that Moncton is among the final 5. P of A is 0.2, P of B is 0.35, and PA intersection B is 0.08. So fundamentally what we were asking is, what is the P A intersection A union B? So the calculation is extremely simple and straightforward. Still, if someone has a doubt, I can explain.
Clear.
All right. How many people got this answer exactly in the first go? Okay.
Yes.
Okay, no problem. Rules for complement, I think I already explained this idea anyways. If any doubt, just ask me, but I think it should be abundantly clear. Probability of A bar is 1 minus probability of A. Why? Why is that? Because A bar is what? S minus A, right?
8 minus.
So if I wanted to calculate the probability of A bar, probability of S is correct.
Yes.
Event S will always happen. The sampler space S will always happen. That's why probability of S is 1. So this is, I think, similar. Okay, how many people know what is the conditional probability? Okay, not much. Okay, so the idea is event A, what if event A or certain event affects the second event? So have you heard like Tokyo Olympics have been kind of postponed?
Yes.
Yes. So now think very carefully. Happening of event like Olympics is dependent on so many other factors. That there should not be any epidemic around the world. There should not be a world war going on or something like that. So the idea is event A can trigger or change the probability of B altogether. Okay. So let's say, how do I say? Uh, about traffic. Let's start with the traffic idea. So if you live in a densely populated area such as Bangalore, so at different times around 8 a.m., 9 a.m., 10 a.m., maybe at 8 a.m. delay of 15 minutes still okay. So initial delay of 50 minutes is still delay of 15 minutes while you are reaching the office. Let's say, for argument's sake, at 9 a.m. initial delay of 15 minutes would be how much delay? Maybe let's say 25 minutes. But at 10 a.m. initial delay of 15 minutes might result into, let's call it 40 minutes. Everyone agrees with me? Means as you go near peak time in India, so if you start at 8 a.m., so 15-minute delay is almost 15 minutes delay anyways, means if it is very linear, okay? But closer to 9 a.m., 15 minutes delay might become 25 minutes delay overall because the traffic is really increasing. And at 10 a.m., 15 minutes delay might become 40 minutes of delay. So you can see the probability of you reaching in time is changing based on what time you have even started at. Do you guys agree with me?
Yes, depend upon the situation.
Yeah, depends upon situation. This is what is called conditional probability. The moment you have to tell that this probability, unfortunately, so remember the coin toss thing? Remember the coin toss example from yesterday?
Yes, yeah, that 50%. Fair coin on?
Fair coin, yes, fair coin, 10 time heads.
Yeah.
So probability of next event is actually dependent what happened already. It's not free of what, it is not like always 1 by 2, and this is what I was trying to explain yesterday. That everyone thinks it is 1 by 2, but it is not actually. It depends on what has already has happened. Okay. So these scenarios are called conditional probability. Suppose that we are interested in computing the probability of event A and we have been told event B has occurred. So the conditional probability is written as, so this means, and the way you pronounce it as say it is, probability of A given B. What it means is calculate the probability of A given B has already occurred. Okay, if it is written like this, then it means probability of B given A has already occurred. Based on the scenario, they might not always be equal. Okay, so the equation is very simple. Probability of A given B is nothing but probability of A intersection B divided by probability of B. So let me explain this through the picture. Now the moment we are told that event B has occurred, then the sample space is restricted to B itself. If someone is saying that calculate the probability of A given B has already occurred, then your probability space has shrunk from the whole S to just the B, because only in terms of B now everything can be defined. And now basically have to find what is the what A events can even happen, but they can of course happen within the confines of B itself, right? Because B is dictating the terms here. So probability of A given B is probability of A intersection B, this area, divided by the total area of B itself. Okay, calculate this one. So an Academy Award is shown to be shown, means Oscars. For a specific married couple, the probability is the husband watches the show is 80%. The probability that his wife watches the show is 65%, while the probability that they both watch the show is 60%. So what the question is asking, if the husband is watching the show, tell me the probability that his wife is also watching the show. So it's conditional, right?
So it is like a husband given to wife
Yeah,
occurs.
that that is what I want you to. So now I think it is
Correct?
wife given to husband. Okay, what you have to calculate is, because husband is already watching, right? So husband event has already occurred. Now you need to calculate the probability of wife is also watching.
0.75.
Sorry, how much?
0.75.
Okay, anyone else?
2 by 3 means 66.66.
Sorry, how much?
6.66. Yes.
Anyone else? You can also type the answer in the chat directly. Good.
60 by 80. So
Yeah,
I mean,
perfect. Yeah. So Academy Award. So basically, you just have to get the
60 over
events,
80. Yeah.
right? So probability of B is husband watching the show is 0.8, and his wife watches the show is 0.65, and their intersection is 6. So you just put in the equation and you solve for it. So whoever got 0.75 or 75% or 60 by 80, they are all correct.
Can you please go to the previous? Got it.
Okay, clear for everyone. If anyone, please ask me a query right now.
Got it.
Okay, cool. Okay, another definition. Sorry about so many definitions. Okay, when events are called independent of each other. Okay, there are two things. First, let me explain properly because otherwise people will get confused. Mutually exclusive and statistically independent. What are these? What is the mutually exclusive event? That I have told you already.
Intersection one.
Good. So basically, mutually exclusive is if you try to take intersection, you get a phi.
Fine.
Okay,
Yeah.
right. What is statistically independent? So mutually exclusive is like getting heads or tails. Right. They're mutually exclusive. Either if it is a single coin, either you will get a head or you will get a tail. They cannot occur at the same time. Okay. What about statistically independent? What is that?
Is it like a sequence of events?
Yes, something with sequence of events, but still, what is statistically independent?
The sample space is different.
Okay, so let me give you an example. Let's say in one hand, you toss a coin. So right hand, I toss a coin. From left, I throw a die. These two events are statistically independent because getting heads or tails or heads, would not impact the outcome of die.
Sorry, can you please repeat it?
Yeah, if using my two hands, with one hand I toss a coin, at the same time I throw a die. So would getting heads or tails in a coin would have any impact on the die or outcome of the die or dice actually I should say dice. if you have in afternoon, does it affect the weather? Yeah. Similarly, the above example, tossing a coin and throwing a die, they are statistically independent events. Getting heads or tails in the coin has no impact whatsoever on the die. Outcome of coin is independent and outcome of dice is independent altogether. Would you agree?
Yes.
So such events are called independent or statistically independent.
Can we say jogging outside? I mean, the rain affects jogging outside.
Yeah, that is statistically dependent because based on the rains, it can affect how many minutes or would you run outside there, yes or no at all. So that is a statistically dependent that cannot be called statistically independent, okay? But me having a tea or coffee in afternoon, it doesn't affect the weather. If it is gonna rain, it will rain. If it doesn't have to rain, it will not rain. Okay?
So statistically independent means like, that occurrence of event doesn't affect at all the result, right?
The other event. So let's
The
say
other
there are
event.
two events A and B. So if whatever happens with A, it has no impact whatsoever on the B, and vice versa. Whatever happens with B has no impact on A. Inhaling air at the time of corona. Would you like to elaborate this? I did not exactly get it. So you are saying it is statistically dependent or statistically independent? That's the question. Okay, so inhaling at the time of corona, which does not impact. Okay, so now this is slightly problematic. So if someone is COVID-19 positive around you, okay, and if they are sneezing, if they do not have a mask on, so coronavirus can live for 1 or 2 hours suspended in the air as well. Okay, it doesn't live long in the air, but it does live 1 or 2 hours. So I cannot say it is totally statistically independent. If someone is COVID-19 positive, that can impact you as well. Yes, it is mostly found on the surfaces and it is mostly spreading through touch. But if someone has COVID-19 and if they start sneezing, there's a probability, small, that the virus will be in the air for 1 or 2 hours.
Yes, because it's a respiratory problem.
Not respiratory, it is still like mostly going through the touch. So it will mostly go on surfaces and you will touch the surfaces. And let's say after touching that surface, you touch your mouth, nose or anything, and that virus will get inside your body. Okay, mostly that's how it is going. But let's say someone has COVID-19 and they're positive. If they start sneezing in front of you, you have to cover your mouth immediately and the nose because coronavirus can stay in the air for 1 or 2 hours, not too long on some surfaces like wood and stuff, it can stay there for 3 days. So comparatively, air is not a big problem. 1 or 2 hours is more than enough, but still for 1 or 2 hours it can be there. So do not think it is completely statistically independent. That would not be the true assessment here. Is it clear?
Yes.
Okay. Okay, first let me explain this difference very clearly first. There's a difference between independence and mutually exclusive, and be very, very clear. Okay, they are not always the same. Okay, remember, mutually exclusive events are highly dependent otherwise. Why? Why we are saying mutual events are highly dependent? Take the example of coin toss. Heads and tails are mutually independent. Mutually exclusive, not independent. Sorry, my bad. Heads and tails are mutually exclusive.
Mm.
Say yes or no. That's all the answer is. Is it
Yes.
not your yes?
Yes.
But yesterday I proved getting more number of heads does affect the probability of tails, right?
Correct.
So they are not really independent. And this is the case in a lot of places that something might be mutually exclusive, but that doesn't guarantee statistical independence as well. It just means that A and B cannot occur simultaneously. But if A starts to occur too much, and if the system is fair or unbiased, it will increase the probability of B happening after a while. But independent events do not have this problem. A and B have no impact on each other. Okay. So it is like A and B is just there, but they do not affect the probability of each one at all. Okay. So such events are called independent events. Okay. Like again, as I explained, tossing a coin and rolling a die from different hands, they are statistically independent events. So getting heads or tails would not change any probability in the dice, the outcome of dice, right?
But can we say in haphazard they are statistically independent?
It's very hard. Doing any kind of analysis on a haphazard random it has proven very hard, and there doesn't exist, according to my knowledge, there hardly exists any definitive theory how to deal in haphazardous world. So I cannot really comment on haphazard. Honestly, even I have very less idea about it.
So haphazard like theoretically exists, but not really used in calculations or
Yeah,
anything.
that's the whole idea that if it is really haphazard, you can't calculate it. That's the whole idea. It means it is like truly random, and if it is truly random, no maths can be done on it. Okay, means it's very hard to control or it's very hard to predict. Okay, so you have seen the additive rule already, and you have seen the rule for complement. Just revising, you have seen the rule for conditional probability and this multiplicative rule where A and B are independent of each other. Now, the only major issue is how to count. Okay, how do we count things? Tell me.
Can we? I have a question before we move on. How we determine the difference between a mutually exclusive and statically independent? Give an example. Is there like a quick way to, like a keyword thing that we can look for to identify the events, or we'll have to think about whether it's mutually exclusive or statistically independent?
So let me put it like this. Mutually exclusive is still easier to detect. Okay. Conditional independence is not that easy in this world. Okay, so I am reading a book basically based on causality. So causality, okay, what causes what? And the whole book explains the problem of causality science, that it is so hard to explain the dependency or the causality, right? There are so many co-founders here. So the problem is this independence part. So many times it is mentioned by the interviewer or the question that they are already statistically independent, right? But in the real world, if you had to truly determine are they truly independent, that is not going to be an easy task. That much I can tell you with experience. Okay, let me give you an example. It's slightly tricky, but try to understand this. Okay, let me put it like this. The increase in temperature raises the sales of sunglasses. True or false?
Yeah, generally speaking, it's true, maybe, but can't say for sure.
Yeah. So temperature, you can can you say temperature is always corresponded or with number of sales of sunglasses?
No,
Why?
because it's not that for temperature rise only we can get the sunglasses.
There may be like a flu situation people are buying because of flu, high flu or something.
I did not get. What did you just say?
People might be buying more sunglasses because of like this eye flu situation. Just like
Yes.
could be
So
the
if you
reasons.
go ski boarding
Yeah.
or you are driving in a scenario, because I was in USA for some time. So if you're driving in a snow, roads are cleared, but snow is all around you. Okay. So when the sun comes up, even the temperature is extremely low, but sun can come up.
Right.
Now that ice will start to reflect, okay, on
Yeah.
directly on your eyes.
Yeah.
So
Yeah.
you
It's
need to
hard to
wear
drive.
sunglasses. Now it looks like temperature and this is directly dependent, but the actual co-founder or cofactor is sunlight.
Light. Yep.
This is the problem. Now this is a causal diagram and we understand the physics of it. That's why I could explain you this. There are a lot of problems where this is not very clear. There
Okay.
are a lot of problems where you cannot 100% say which one is dependent on which. Okay, sometimes there is a circular relationship. And then you are screwed.
Okay.
Understand? There can
Mm-hmm.
be a circular relationship between various things. So
Yep.
if you alter one thing, it will alter something different, and that will alter something different. So you can say this one and this one is statistically independent till you do not consider this. But the moment you consider this, then you know they are not really statistically independent. So first of all, it is a hard task. Not everyone, unless you already do not have a great knowledge about the system, you cannot actually say this kind of stuff. It's very hard. Mutually exclusive is easy to tell.
So that means that treating a statement like a problem statement, if it is easily identified as mutually exclusive, then we can say it is mutually exclusive. Otherwise, it may have really a high degree of probability that it is not mutually exclusive and basically statistically independent or dependent.
Yeah, most of the systems are statistically dependent. You have to understand this. There is some kind of statistical dependence between them.
Mhm.
It's very hard to prove that they are not, they are completely statistically independent. So most of the times when an interviewer or some system or some person asks you this question, they will tell you the assumption that yeah, they are statistically independent or they are statistically independent. But yeah, if you wanted to just determine, go out in real world and just say, yeah, is these two things statistically dependent or independent? I have to find out. That can lead to a research study altogether.
All right, let's forget that then. Let's move on. Sorry.
Okay. Yeah, no problem. This is actually a very interesting problem. Even in field of AI, we face this regularly. There could be various variables and you will face this exact same problem in machine learning. You need to know which variables are associated with the outcome and which one are not. So this is actually a very pertinent question and thank you for asking this. But remember, this is not an easy problem. This can become very hard as you go forward. Okay, just we
Can
have
we
10. Yeah.
can we say the other way around? Like if statistics says it is dependent, then can we say it is dependent?
Yeah, if the
Actually,
question mentions it, it is independent, go for it, no
no.
problem.
I am saying if statistics means the already those events already happened. If those statistics match our expectation, can we say those are dependent?
Yeah, okay. The problem is statistics is done on the data collected, okay? You go out in the real world, you collect the
Yes.
data. We
Yes.
will have the class for sampling as well. The problem is, what if there are dependent events internally and you forgot to factor about them? Then it can ruin your whole statistical study as well. And this is a major problem in a lot of statistical study around health effect of a virus and whatnot. Okay, because there are so many factors which you might choose to forget and you think, oh, these two things are like the assumption, the air assumption, right? With the what a person mentioned on like our chat very recently, and that I started discussing. Yes, you are true that it goes through touch, But you cannot say transmission through air is 0. You cannot say that. But if you make that assumption in collecting the data, you will miss the people, or your probability will be shifted, because some people might have gotten infected through the air, even in a short term, but they might have been. Let's say you are traveling in the bus, or in grocery shopping, you are seeing how many people are standing very near to each other. So someone is COVID-19 and they sneeze in front of you, there's a high chance you might also get it just through the air itself. Even it doesn't actually propagate through air, but for short term that can happen. So if I forgot to collect that data, my whole study will be wrong. So it is not an easy process. It's a very complex process that we are trying to address. So in determining independence is a hard problem. Okay.
Okay.
Okay. Okay. So now the only major last topic is counting, how to count. So this is the equation, and you can see that fundamentally to count the probability or get the probability, I need n. What is this number? How many number of elements of A? Sometimes it is exceptionally easy. You can immediately look at the question and you can say, yeah, it is 2 or 3 or whatever it is. But sometimes it can become hard. So suppose we carry out having a set A1, A2, A3, different events, and that any pair are mutually exclusive. So A1 union A2 is 5. So counting is extremely easy over there. So if I ask you to get the union of all the events, what would be the total number? A is the subclass, superclass, sorry. So A is constructed out of A1, A2, and till AN, okay, let's call it. So if I ask you to get the probability of A, how would you get it? You will simply get the probability of, number of A1 plus number of A2 plus number of AN, okay? Sorry, I think I skipped. So the probability is nothing, it is N1 plus N2 plus N to N, okay? It's simple, right? Because all of them are mutually exclusive, so there is no common element. So it will literally look like this. Is it clear?
Can you please go to the 57th slide?
This is the equation of probability.
Number of counter events. Okay, got it. Yeah.
So this one is easy, right? You just get the numbers in all the sets A1, A2, A3, A4, and cause they are just mutually exclusive, you can just add N1, N2, N3, N4, and you can get your value, right?
Yeah.
Okay, so this one is easy. What if you carry out two operations in sequence? Sequence is one after another, okay? So you take first coin and then you take the second coin. So that calculation goes like this. The number of ways the first operation can be performed and the number of ways the second operation can be performed once first operation has been completed. So basically you have to, let's say you have cards, okay? So how many cards are there in a standard deck? 52 card, okay? So if I have to choose, I have to take out two cards one by one, okay? So how many ways are there to choose the first card? Let's say there are two positions to be filled. So how many ways there are to be, you can get first card? How many options
52.
you have?
52 ways.
52.
Very good. But now you took one card and there is no replacement. So you do not replace that card with anything else. So what is the next one?
51.
Very good. So number of ways you can take two cards one by one is, so you can do 52 into 51 and that would be the n. So number of ways that two operations can be performed in sequences, n is equal to n1 into n2, given they happen in one by one sequence only. And you can think them like this as well, like a tree structure. First n1 will happen, 5 choices in n1, and let's say n1 is also 5 choices, n2, sorry. So it basically becomes 5 into 5, 25. Answer this question and we will end today's session. So we have a committee of 10 people. We choose from this committee a chairman and a vice chairman. How many ways this can be done?
In first count, we'll choose chairman, and second count.
It's a simple idea. And for chairman and vice, VC. Okay, let me write it like VC. So for chairman or chairperson, how many options we have?
10.
Very good. But now it is a group of people, and once you select the chairperson,
then the count is less.
Yes, there is one less person now. So there is 9 only. 10 into 9 is?
90.
Yes, very good. Okay. Okay, guys. So as I have said yesterday, today is Ugadi. So I would like to stop the session for today. What I will do is I will upload this slide as well on your drive, Google Drive. Okay. And I will upload few books. So you guys can get started now and you can start reading few things. And tomorrow when I will finish this, we can have few assignments as well to solve the equations or problems of probability. Is it okay?
Yeah, sure.
All right.
Sure.
Okay, guys. So,
Thank
okay, make sure.
you.
Yeah, go for it.
For the previous assignment you have given yesterday.
Already submitted. I'm still waiting for the rest of the people, but I will reply the people who have submitted till yesterday night. I will try to reply to them today itself. Okay.
No, I just want to say that, is there a better way to execute the program because it is taking too much time. I think
So
it's
what
about 10 minutes or 15 minutes. So,
what are you trying to program? Can you again say? Sorry.
uh,
Which one is
I was
taking time?
using a for loop and run it for like 1 lakh times and
Oh yeah, no, sorry, you cannot do much actually. Yeah, that is supposed to take 5 or 10 minutes, depending on your computer. You can use Google Colab. Google Colab will be faster for you. If your
it's
system
taking
is
my
slow.
machine first.
How much is it taking?
Google Colab took it like 15 to 20 minutes, but my machine gave it to me in 12 minutes.
Weird. Okay, maybe you have a good system then, but even Google Colab has a good configuration usually. No,
No,
not
Google
much you
Colab has
can.
12 GB of RAM, 8 GB, but
Okay,
my system has 16.
okay, then maybe that. So did you get the graph right?
Yes.
Yeah, that is why I gave you that, so that you had to calculate it again and again. Not much can be done unless you mostly you have to just use NumPy operations over there. So if you are
Yeah,
using it,
I will use that. But the for loop and the
yeah,
size
nothing
of the
can.
arrays keep
Yeah,
increasing. That's why
okay,
it's
okay.
taking.
Yeah, I got it. Maybe you can take a smaller size, but not much can be done. Look, there are only two options. You have to produce 0 and 1 randomly, okay? And every time you will keep increasing this 0, 0. Maybe all three are 0, okay? And then
Will
the
it be
size will.
faster? Will it be faster if I write the data to a file, local file?
No,
Read it well?
again, so who will give you this data about heads and tails?
Yes, it will be taken wrong. But
Right.
without storing it inside a list or array,
You have to
it
store
will
it
be
in a
faster
NumPy
in.
array. Okay, so you
Yes.
have to still store it in somewhere.
Mhm.
Like what data structure you will use. That's the
Yeah.
problem, right? You still have to
Yes.
store it somewhere.
Mhm.
So Again, this is a small exercise. Don't worry about this. This is not like really a programming question. Just to show yourself, how did the graph look for you?
It came around 0.5.
I
Firstly,
mean,
it was sharp high, sharp low, then
yeah.
it
So let me
kind of
predict.
settle around 0.5.
Yeah, basically, let me predict something like this would have happened.
Yes.
Yeah, this is what I wanted you to see with your own eyes. That even in short term, you can get a lot of heads, lot of tails. Okay. In long runs, it will just settle down for 0.5.
Yeah.
Okay. It was just to show yourself and the idea of stochasticity, that it cannot just keep going in one direction. If it is going in heads for some time, it will also come down for tails. So it will create that balance after a while.
Yes. Okay.
Okay, cool. Okay, guys. So see you all tomorrow at 8 a.m. and we will finish probability hopefully tomorrow. Okay. Okay, guys. Finishing off the session. Have a good day. Okay.
Yeah,
Okay.
thank you.
Okay.
Thank you.
Happy.